In this lesson, we're going to take a look at finding distance. Simply, if I have two locations, how far is it from one to the other? Now, most times it's easy because we would just look and count from one location to the second. We would count over how far I've traveled. Or, if I was like this, I would count from one spot to the other and figure out how far I've traveled. The issue comes in, what happens if it looks like this? How do I find distance of a slanted piece? In my first example was horizontal, my second was vertical. What do we do for a slanted piece? So let's do this on graph paper and take a look. So I'm going to do this ordered pair, which is -4, 3, and this ordered pair, 4, -2. I want to know what the distance is from here to here. Now, what a lot of kids would try to do is count. Okay, here's 1, 2, 3, 4, 5, 6, 7, 8. The issue with trying to count a slanted piece is that in any square, let's say that's a unit length of 1 and a height of 1, the diagonal is not equal to 1. And why is this? If I would zoom in on this picture, this is 1, my picture's off. Now think about this. This is a right angle. What do we know about a right triangle? This side is a leg, this side is a leg, this side is my hypotenuse, which is always the longest side. That's my hypotenuse. That's my longest side. So because this is my longest side, I know that it's not the same as my two legs, which proves I can't go and count my diagonal stretches each as one unit. So what do we do with that? We want to find out what my diagonal piece is. Well, what we can do is we can take the picture we have and add to it. So here's what I'm going to do. Okay, I have this stretch from this point to this point. What I'm going to do is go ahead and add in the imaginary right triangle that formed it. Okay, what calculations can we do with right triangles? Well, we do know a squared plus b squared equals c squared. We know the Pythagorean theorem, so let's apply this. So I'm going to look at A here, which is 1, 2, 3, 4, 5 in length. B is 1, 2, 3, 4, 5, 6, 7, 8 in length. And I'm going to go ahead and calculate this. Why? Because I'll be able to figure out what my diagonal length is. So A squared, 5 squared plus 8 squared equals c squared. 25 plus 64 equals c squared. 25 plus 64, 89, equals c squared. I want to get c by itself. I'm going to square root. C, I need the square root of 89, which is roughly 9.4. So the square root of 89 is roughly 9.4. So by doing this, I have found the distance from this point to this point to be 9.4. How? By adding in my right triangle that shows me the relationship between the legs and the hypotenuse. So what I can do is, to find distance, just use my Pythagorean theorem. Let's look back real quick. -4, 3, 4, -2. -4, 3, 4, -2. What if I have two ordered pairs and I'm trying to find the distance between them and I don't have graph paper. Or my distance on the graph paper is too big. You know, the ordered pairs are in the hundreds or the thousands. There are other ways to calculate this using the same concept. I want you to think about this. If I go back, how did I know what this length was? First of all, I counted, but what if I just knew this? Here's this ordered pair. How far down do I need to go to get to be in line with the same other ordered pair? Well, think about what direction I am working in here. I'm working in the up and down direction, which is the y direction, the y-axis. So let's go over here and say, what numbers am I concerned with? I'm concerned with the y values. It was 5 from this ordered pair to be in line with my second ordered pair. It was a distance of 5. How can I use these numbers to figure out a distance of 5? Take a look. This one is 3. This one is -2. What I can do is subtract and find the difference between them. Now I'm going to add in this picture. This is called the change of y. So I figured out my change of y. The change in y, that's what this symbol means. This is actually called a delta symbol. Change in y. How do I find it? To find the change in something, the difference between the two, I subtract them. So I took my two y values and I subtracted. 3 minus -2, which is 5. Okay, I'm going to go back. And I want to look at how did I find from this distance over to be in line with this distance? Okay, in other words, how did I find B? The way I found B was looking at this point, finding how far it was from this point. What direction is that traveling? That is my x direction. So my distance was 8. Can I find a way to get 8 from these two numbers, my x numbers? It's the change in x. How did x change? It changed a total distance of 8. So I can find my distance between these two numbers. 4 minus -4 gives me 8. So this is the general concept of using my x and y values to actually subtract if I don't have graph paper in order to find this side and this side. So what does this all look like? We're going to take a look at specifically what is the distance formula. And here's what it is. We're going to take the pieces we just talked about and use an actual formula, and all we need to do is fill in values. It looks like this. D, which is distance, is equal to the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. Now, where does this come from? Let me show you real quick. C equals the square root of a squared plus b squared. How do we get this? By solving the Pythagorean theorem for the letter C. So let's take a look at using my same two ordered pairs, but I'm going to use this formula and see if we can't come up with the same thing. Let's see what my ordered pairs were real quick. -4, 3, 4, -2. So I'm going to use my formula. D equals square root x2 minus x1 squared plus y2 minus y1 squared. So in my ordered pairs, I'm going to get two ordered pairs. I need to identify what counts as my x1, what counts as my x2. What does that mean? If you look at this, this is my first ordered pair. This one here. So which is the x number? The -4 is. Which is the y number? 3. So because this is my first ordered pair, I'm going to call this x1, y1. This is my second ordered pair, so I'm going to call this x and y because all ordered pairs have an x number and a y number. This is x2, y2. All I need to do now is substitute these values into my formula. So d equals square root. Instead of x2, go up top and look for x2. There's x2. 4. 4. That's done. That's done. Minus x1. Where's x1? Minus -4. That's done. That's done. And I'm going to square that. Plus, what's y2? y2 is -2 minus, that's done, that's done, y1. Where is y1? Here it is, 3. That's done, that's done, squared. I'm going to now do order of operations. Here we go, parentheses first. -4 plus +4. I'm sorry, 4 minus -4, which is now 4 plus +4. 8 to the second power. Plus -2 minus 3. -2 plus -3 is -5 squared. Next up, exponents. -8 squared is 64 plus -5 squared. Now think about this. -5 squared, -5 times -5, 25. D equals square root of 89. And I have to look back, see what we said that was. That was 9.4. So D is equal to a distance of 9.4. Let's try one more. Let's make up some ordered pairs. Let's go 25, 17, and -11, 26. And I want to find the distance between them. My first step is I'm going to label them as x1, y1. x1, y1. Y because it's my first ordered pair. x2, y2 because it's my second ordered pair. Each ordered pair has an x value and a y value. So let's use my distance formula. D equals square root x2 minus x1 is quantity squared plus y2 minus y1 quantity squared. I'm ready to substitute in my values. x2. Look for x2, which is here. -11. x2 is done. x2 is done. Minus x1. x1 is 25. Squared plus x1 is done. x1 is done. Next up is y2. y2 is 26 minus y2 is done, y2 is done. y1 is 17 squared. y1 is done, y1 is done. Why am I crossing these off? Mainly because they're all so similar, x1, y1, x1, y1, y2, x2. I want to make sure that I've crossed them off so I don't like double write them or double count them. Order of operations, parentheses is first. -11 minus 25, -11 plus-25, -36 squared plus 26 plus negative 17, which is 9 squared. D equals negative 36 squared. Negative 36 times negative 36. 1296 plus 9 squared, 81. I'm going to add those up. Running out of room. Square root 1296 plus 81. 1377. Square root 1377. And I get a distance of 37.1. So again, this is distance formula. How do I take two locations, which will be listed as ordered pairs, and how do I find the distance between them? If it's on graph paper, I can use Pythagorean theorem, but I can also use the distance formula. And again, the distance formula is D equals the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. And finally, where did that come from? It came from the Pythagorean theorem, a, b, c, which is a squared plus b squared equals c squared. All we did was solve for c, and it came from c equals the square root of a squared plus b squared. Okay. Good luck.